In 2013, Explorer 1 accomplished a notable achievement by becoming the first human-made object to enter interstellar space. This exceptional accomplishment happened 36 years after its flight from Earth. The space probe currently resides 14.5 billion miles from Earth, requiring almost 2 days for the transmission and gathering of messages. NASA designers never guessed that Explorer 1 would continue its space exploration for almost 50 years. In 2013, Explorer 1 identified 500 unidentified objects traveling through space, sparking significant conversation. Undeniably, popular podcaster Joe Rogan joined the discussion to shed light on the disturbing ramifications of this uncommon disclosure. These mysterious objects could be crafted by extraterrestrial beings or simply a glitch on the spacecraft. The mystery has fascinated researchers for a long time, but the recent phenomenal experience in deep space has sent shockwaves through mainstream scientists, possibly revealing insights into the age-old inquiry of the presence of aliens. Joe Rogan, a prominent reporter and podcaster known for his keen interest in discussing extraterrestrials and the possibility of advanced civilizations, has previously hosted guests such as David Grush and Avi Loeb to explore the potential for life beyond Earth. The historic Explorer 1 mission was conceived during the 1970s when NASA researchers had the opportunity to truly grasp the scale of our infinite neighborhood. Everything began with an unintentional alignment of Jupiter, Saturn, Uranus, and Neptune, the 4 largest planets in our solar system. A young PhD student named Gary Flandreau discovered an astounding celestial phenomenon that would steer space exploration in the late 1970s and early 1980s. The 4 planets aligned in a captivating formation resembling pearls on a grand necklace, with Earth nestled among them. This discovery sent waves of excitement through NASA as it introduced a remarkable opportunity to improve the trajectory of a space probe by cleverly utilizing the gravitational pull of each planet during flybys. Flandreau estimated that these gravity assists from the giant planets could shrink the flight time between Earth and Neptune from 30 years to 12 years. However, this celestial alignment happened only once every 176 years, prompting NASA to embark on an ambitious mission to capitalize on this once-in-a-lifetime opportunity. Explorer 1 and Explorer 2 were twin spacecraft launched in 1977 to investigate the mysteries of the solar system. Launched 15 days apart, they became essential parts of NASA's Explorer space program, a testament to humanity's unquenchable curiosity and quest for knowledge. For almost 50 years, Explorer 1 has been transmitting valuable data back to Earth through NASA's Deep Space Network, bridging the gap between our earthly existence and the mysteries that lie beyond. Explorer 1's remarkable journey is as inspiring as it is distant, currently residing 24 billion kilometers away from Earth, making it the farthest man-made object from our planet. The spacecraft was meticulously designed and built by NASA's Jet Propulsion Laboratory and began its historic odyssey from Launch Complex 41 at Cape Canaveral Air Force Station, propelled by a Titan IIIe launch vehicle. One key feature of Explorer 1's launch was the presence of dual redundant computer systems. Both Explorer 1 and its twin Explorer 2 were equipped with 2 sets of command computer subsystems, Flight Data Subsystems (FDS), and Attitude and Articulation Control Subsystems (AACS). This redundancy ensured smooth transitions between systems and the ability to activate dormant computer components when necessary, effectively extending their longevity. The computer systems on board Explorer were organized as a distributed system with 3 redundant pairs of computers, ensuring that if one system failed, the other could seamlessly take over, preventing critical failures. Power management is a significant component for maintaining the operational integrity of Explorer 1, especially as the spacecraft's distance from the Sun, where it can harness solar energy, poses a considerable challenge. Engineers needed to devise innovative ways to conserve and optimize power use, including implementing specific power shutdowns for non-essential systems. In summary, Explorer 1 and Explorer 2 have been instrumental in unveiling the secrets of the nearby solar system and interstellar space, providing crucial insights into the vastness of space and the mysteries that lie beyond our understanding. Explorer 1 is a space explorer that has defied all expectations, sending back vital data nearly 50 years after its launch. Initially intended to last only 5 years, Explorer 1 has been equipped with a vast array of scientific instruments, suites, and subsystems. These instruments were strategically placed on the spacecraft's body, which comprises a staggering 65,000 individual parts. One of the enduring instruments on both Explorer 1 and Explorer 2 is the low-energy charged particle detector. This instrument boasts 3 sets of particle sensors that measure the number of low-energy particles striking it, as well as their velocity. It continuously monitors cosmic radiation and particles originating from the Sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Detector, actively searches for high-energy particles from both the Sun and other cosmic sources. The plasma wave subsystem, featuring two elongated antennas oriented at right angles to each other, serves as a crucial tool for measuring the electric field components of potential waves encountered at the outer planets. However, its role has evolved as the explorers ventured into interstellar space. Over the years, engineers have made remarkable technical advancements and improvements in power management strategies, including more efficient power distribution, enhanced battery charging techniques, and advancements in power regulation and control. Explorer 1 continues to send back significant data, showcasing the dedication and ingenuity of the scientists and engineers who have worked tirelessly to keep it operational. The Explorer missions, initially designed to study the magnetic fields of outer planets, have undergone massive transformations as they progress into interstellar space. The magnetometer, originally intended to focus on the magnetic fields of outer planets, now plays a significant role in investigating the transition region between interplanetary and interstellar media. This instrument is used to study the magnetic characteristics of the transition region at the boundary where the Sun's magnetic influence interacts with and gives way to the magnetic field of interstellar space. The Plasma Science Instrument, which examines the lowest energy particles within the plasma, is currently operational only on Explorer 2. This instrument is a testament to the ongoing scientific exploration NASA has undertaken. The agency has systematically deactivated radiators on both spacecraft after 21 years of operation, and non-essential instruments have been permanently turned off. The power source for each spacecraft is 3 radioisotope thermoelectric generators, RTGs, which utilize the heat generated by the radioactive decay of plutonium-238 to produce electricity. As plutonium-238 continues to decay, it will eventually be unable to provide power, leading to the suspension of all instruments around 2025. To extend the operational life of both spacecraft until 2027, the Explorer team is employing meticulous power management strategies. Each spacecraft is equipped with engines to maintain communication with Earth, and the primary transmitter emits around 20 watts of power. However, the strength of the signal from Explorer 1 reaching Earth is 20 billion times weaker than that of a digital watch battery. One's journey through space has not only expanded our understanding of the solar system but has also provided critical insights into the nature of the heliosphere, the bubble of charged particles surrounding the Sun. As Explorer 1 moved further from the Sun, it began to experience different environmental conditions than those encountered by previous spacecraft. Perhaps one of its most significant contributions has been its role in mapping the structure of the heliosphere and its boundary, known as the heliopause. This boundary marks the transition between the solar wind and the interstellar medium, where the influence of the Sun wanes and material from other stars begins to prevail. By sending back data from its plasma wave instrument, Explorer 1 has helped scientists better understand the behavior of plasma in this transitional zone. This information is crucial for understanding how cosmic rays from outside the solar system interact with the heliosphere and how these interactions influence space weather. Such insights are vital not only for astronomy but also for safeguarding future spacecraft and astronauts from harmful space radiation. Another noteworthy aspect of Explorer 1's mission is its contribution to the study of magnetic fields. As Explorer 1 crossed the boundary into interstellar space, it provided the first direct measurements of the magnetic field beyond the solar influence. These measurements have been pivotal in enhancing our understanding of the magnetic environment of the interstellar medium. The data collected helps researchers illustrate the magnetic interactions between different regions of space and understand how these interactions influence cosmic phenomena. Explorer 1's longevity and continued data transmission have also led to an improved understanding of the dynamics of interstellar dust. The spacecraft's dust detector has been instrumental in measuring the density and velocity of interstellar dust particles. These measurements provide valuable information on the composition and distribution of dust in our universe, which in turn influences theories about star formation and the evolution of the interstellar medium. The spacecraft's ongoing mission has also shed light on the development of technology used in space exploration. The engineering accomplishments achieved by Explorer 1's mission have set a benchmark for future deep space missions. The innovative design and resilience of Explorer 1's systems have influenced the development of subsequent spacecraft, demonstrating how engineering solutions can extend the life and effectiveness of space missions far beyond initial expectations. In addition to its scientific achievements, Explorer 1 carries with it a symbolic message to any potential extraterrestrial civilizations. The golden record, containing sounds and images chosen to represent the diversity of life and culture on Earth, serves as a universal greeting and a testament to humanity's desire to connect and share its existence with the universe. This message, along with the spacecraft's data, represents a significant milestone in humanity's quest to explore the universe and engage with other intelligent life forms. Overall, the Explorer missions have made significant strides in their exploration of interstellar space and the mysteries surrounding the discovery of 500 unidentified objects. Explorer 1, a space probe, has detected 500 unknown objects in the depths of space, igniting a wave of concern among scientists. Initial data transmitted back to Earth was chaotic and resembled a garbled message from the universe. NASA's Jet Propulsion Laboratory was astonished by the confusion and found that the Attitude Determination and Control System, AACS, had switched to using a faulty onboard computer that had been dormant for years. This led to distorted telemetry data. NASA scientists quickly resolved the issue by reconfiguring the AACS to transmit data through the correct computer. Uncorrupted data from Explorer 1 is now streaming back, but the question remains: what caused the AACS to utilize the failing computer in the first place? NASA researchers have yet to provide a definitive answer, but they have suggested a theory proposing that the AACS received a faulty command from another onboard computer. Suzanne Dodd, project manager for the Explorer interstellar mission, revealed that a thorough memory readout of the AACS will be conducted, followed by an exhaustive examination of its operations to identify the root cause of the telemetry issue. Several factors could contribute to the inconsistency, including the ambient conditions of space, cosmic radiation, dramatic temperature fluctuations, and exposure to micrometeoroids such as dust particles and fragments from asteroids and comets. As Explorer 1 ventures into interstellar space, its plasma wave instruments have consistently detected the effects of dust particles due to their high radial speed. When a dust particle collides with the spacecraft, it immediately disintegrates and ionizes, creating a growing plasma cloud that triggers a voltage pulse in the electric antenna of the plasma wave system. While various conventional theories have been proposed to explain the misfire in Explorer 1 systems, one possibility that captures the imagination and belongs to the realm of science fiction is the involvement of extraterrestrial beings. However, this hypothesis is highly speculative and not widely accepted in the scientific community. The concept of intelligent extraterrestrial life has fascinated researchers and space enthusiasts alike. Joe Rogan, a well-known podcaster and media personality, has explored this topic through discussions with scientists and UFO enthusiasts, particularly David Grush, a former Air Force intelligence officer and representative of the Public Observation Office to the Unidentified Aerial Phenomena Task Force. These conversations have fueled interest surrounding Explorer 1's anomalies. Rogan believes that the universe is vast, containing billions of worlds, stars, and possibly even more planets. The possibility of intelligent civilizations elsewhere in the universe raises intriguing questions about their potential interactions with Earthlings. If these extraterrestrial beings happen to discover Explorer 1, they might have observed our spacecraft as it traversed the cosmos and chosen to investigate it out of curiosity. This scenario suggests that the anomaly could be their way of sending a cosmic message, a form of interstellar greeting. The Golden Record, a remarkable artifact aboard Explorer 1, serves as an interstellar time capsule designed for any intelligent life that might encounter it. If extraterrestrial beings managed to access the Golden Record, they would interpret a wealth of information about Earth's cultures, languages, and the magnificent diversity of life on our planet. This raises significant questions about how they would interpret our music and art, and what they might conceive of our languages and scientific knowledge.